All right. Today, we're going to move into chapter 22. So we're skipping over section 5, aromatic compounds. I do just want to point out one thing in chapter 5. So structure. You see it represented like that. It's called benzene. Really what it is, so it's 6 carbons in a ring, and we have double bonds on every other. Okay. The reason why we put the circle in there is that when we learned more about it, we realized that the electrons in these double bonds actually tend to spread out, and it looks more like 1.5 bonds across the entire thing. Anyway, so this is the structure. So it's 6 carbons, double bonds, every other 6 hydrogens. If you ever run into it and say, like we have, put an ethyl group right there. It's just like naming a whole bunch, or naming the other ring structures. We put this as carbon 1 because it's the lowest possible number. So this would be 1 ethyl, and then you just say benzene. But as far as properties and things like that, just for the sake of time, we're going to skip over that section. So we're going to go into chapter 22. Chapter 22 is where we start to add things besides just carbon and hydrogen into the molecule. So when we have an organic molecule that has a whole bunch of, carbons and hydrogens and all of that, and then we've got these extra elements. Now, there can be a whole lot of different things that you can throw onto a carbon molecule, but the ones that we are going to talk about, they have specific patterns that we're going to learn to recognize. We call them functional groups. And there is a list of functional groups on page 787. So we're going to go through, we're not going to get to all of them today. I think we're just going to look at 4 different ones. But the nice thing is, as we go through this chapter, and we're introducing functional groups and things like that, the naming rules are really, we already have the foundation. We're just going to be changing a few things here and there for these different functional groups. So anyway, the first functional group, they are called halocarbons. Okay. So what we really have is halogens. And reminder, halogens are group 17. Okay, so if we look at our periodic table, we see fluorine, chlorine, bromine, iodine. That means we're going to add one of those onto this molecule. Now, that should make sense because remember, go back to our Lewis diagrams. So we've got this one electron there that's ready, and halogens have 7 valence electrons. So it pairs up really well. So halogens will do that. Now, when we name these, once again, the rules, mostly we've already established. So if we look at this, put chlorine right there. And what we do is we find our parent chain. That's going to be the first thing that you always have to do. You need to know where our parent chain is. Okay. With this, it's pretty straightforward. You can count 1, 2, 3, 4, 5. So we're dealing with pentane. So we have this chlorine here, so it's not just pentane. What we do is we just have to take the root of this. We get rid of the INE and replace it with O. So this is chloropentane. But once again, this chlorine can be in multiple places. So we need to number our carbons. We want to make that number for the chlorine as low as possible, which means starting over here. 1, 2, 3, 4, 5. So this becomes 2-chloropentane. If, let's say, we add chlorine there, okay? Just like if we have methyl and ethyl, we have to put them all, and we have a specific order that we need. And just like that, we do them alphabetically. So C comes before F, so we get 4, 4O, 2, 4O. So 2-chloro, 4-chloropentane. It really is pretty much the same as all of our other branch chains. Okay? Except instead of having methyl, ethyl, propyl groups, we have chloro, fluoro, bromo, and iodo. Okay? Other than that, the rules are honestly the same. So, the book does introduce the concept of substitution reactions. What we have is, well, it's a substitution. So if we had, let's just say we had ethane here. And we've added it to chlorine gas. Essentially, what's going to happen is this chlorine is going to kick out a hydrogen. So we're going to get this chloroethane and hydrogen chloride. That's a substitution reaction. Pretty straightforward, right? We're substituting one thing for another. And that's how we make these different compounds. So, it's called halogenation. But yeah. All right. So that's halogens. Now we're going to talk about a few more functional groups. Okay. 3 more to be precise. Alcohols, ethers, and amines. So whenever we have a functional group, we have a way that we can write just the functional group. For the halocarbons, typically what we do, we say R and then X. Now that X can be any of the halogens. And then the R is the hydrocarbon. So when we see R, we know that we're dealing with a carbon chain. When I say carbon chain, it really could be just one carbon, because remember, that could be what we're talking about. Anyway, for alcohols, what our functional group looks like is OH. So we have our hydrocarbon, and then we have OH. So basically what we're saying is now when we draw this right here is a carbon, but that's attached straight to the oxygen. So there's only 1, 2, 3, 4 carbons in that drawing. What we're looking at, we do the condensed structure right here. Is that. So 4 carbons with that OH. So once again, first step, we need to identify our parent chain. We need to know how many carbons are there. We've already done that. There's 4. So our prefix is bute. But we're no longer going to end it with butane. Now we do use the AN, but if we have this OH, it's an alcohol, so we put OL. This is butanol. But that also has 4 carbons in the parent chain, but it's a different molecule. So we have to identify where this functional group is. Once again, numbering. And just like always, we want to make the numbers as low as possible. So in this example, we number 1, 2, 3, 4. And that OH is attached to carbon number 1. So it's 1 butanol. This, we'd actually number from the same side. But this becomes 2 butanol. If we have 1 carbon or 2 carbons, we don't need to number because it's always going to be essentially 1. Okay. So it's just methanol or ethanol. But once you get to 3 carbons, then you definitely have to tell us where that is. So, just as sort of a precaution, we can have 2 on there. Okay. And what this would become is 1,2 butane-diol. Now, when I was in school, they taught me different rules, so that still sounds weird to me. When I was in school, they didn't have the NE, but whatever. So, I typically, on homework and tests, don't give you multiple functional groups, but just so you're aware, it can happen. Ethanol is the alcohol that is in drinks. Okay. Anybody who's drinking an alcoholic beverage, they are drinking ethanol. Ethanol tends to be taxed pretty heavily, at least here in the United States. And so we don't typically want to use ethanol if we can avoid it. But if we are going to use ethanol, what we do is we use something called denatured ethanol. And basically what they do is they put a small amount of something else in it that makes it unfit for human consumption. A lot of times that's just methanol. So methanol can actually make you go blind. So you shouldn't drink it. And so they put a little bit of that in with the ethanol. So for example, I've got ethanol right here, but it is denatured. If this was not denatured, the taxes on it would make this bottle pretty expensive. As it is, because it's denatured, it has a couple bucks. So alcohol. Let's move to ethers. So our functional group looks like this. So this one we actually have two separate hydrocarbons. They're separated by an oxygen. Now we use R prime to indicate that they don't have to be identical. Okay. So we can have on one side, we'll just put 2 carbons there, and then put 3 on the other side. Now these are actually really easy to name, because all we have to do is count our carbons. So we have 1, 2 here. So ethyl, because that's our prefix for 2. 1, 2, 3. Propyl. So we have our 2 carbon chains. And once again, it's alphabetical. So we're going to pick ethyl first. So this becomes ethyl, propyl, ether. That's all it is. Ethyl, propyl, ether. If we were to add a 4th carbon there, that would change from propyl to butyl, which would then change the name. Now the B is going to come first. Butyl, ethyl, ether. Okay. And then, let's say we do this. So now there's 4 carbons on both sides, and both of them are butyl. Okay. For this, once again, I was double checking the rules because this has changed since I was in school, so I want to make sure. This one is just butyl ether. I was taught to call it dibutyl ether, but we got rid of that. So anyway, butyl ether. So ethers are actually really easy. You just have to count the carbons. And then the last functional group for the day. We have our amines. Okay. And for this, that's our functional group, NH2. Okay. So this one's not too bad. Okay. So we have our amino group. And let's say, throw a few more there. And we have that. So once again, find our parent chain. 1, 2, 3, 4, 5, 6, 7. So 7 is het. Okay. All we have to do is we have our parent chain, and instead of heptane, it's heptanamine. So that is the rule when there's only one amine group. If we have two, then once again we go back to using the E there, and then di, tri, tetra, whatever it is. So a lot of these are going to have more common names. Okay. Something called aniline is it's a benzene ring. So that's more of a common name rather than the official IUPAC name. We also see this with other other functional groups that we've dealt with today. The name ether, okay, is actually a common name for just ethyl ether. So sometimes it will be called just ether. We try not to do that because it can be a little bit confusing. We also have things like ethylamine, which once again is a little bit different than this. Still very similar, but yeah. Anyway, that's one thing to look out for as we are talking about a lot of these compounds is instead of always calling them by their IUPAC names, a lot of times you're going to find common names in literature. Now, an example of an amine in real life. Okay. This is a little bit of an unpleasant example, but anyway, there are two compounds. They're called putrescine and cadaverine. And they are quite literally the smell of death. If you've ever heard of cadaver dogs, so after like a big earthquake, after a little while, instead of trying to rescue survivors, they are now trying to find victims. And they actually train dogs you can train them to react to a certain smell. If you go to the airport, you're going to find drug sniffing dogs. But cadaver dogs, they are trained to react to these two different amines, the putrescine and cadaverine. And they are able to find people who have died in these natural disasters. Police often will actually use them if there has been a suspected murder and they're trying to find the body so that they can build a case. But anyway, those are amines. They are natural compounds that organic bodies are going to generate as they decompose. So, anyway, so we're going to stop there today. Those are the different functional groups. That's the word I was looking for. Before we stop, actually, I wanted to mention one thing. We never fully finished this, so that's 3. Also, with all of these, we can add extra functional groups, well, not functional groups, branched chains. So we have these, they follow the exact same rules that we've already gone over. The only difference is when we're numbering them, the functional group is what matters. So just like with our double bonds. But everything else stays the same. So this is going to be 5 ethyl 4 methyl 3 heptane. So just because you will see branches like that. Anyway, so we'll stop there. We will leave the rest of those functional groups for next time. And I'll write the homework on the board and get started.